call thing that shows up, and it'll show us right here that the value of favorite number is 0. Now, this function, however, is set so that whatever value we pass it is going to change the favorite number to whatever we pass it as. So if we pass 1, 2, 3, hit store, that transaction goes through, and then hit favorite number, we can see the value is now 1, 2, 3. Now, I will also be using transactions and smart contract interactions and function calls a little bit interchangeably. That's because on a blockchain, whenever you call a function or whenever you make some state change to the blockchain, you're actually also making a transaction. That's what makes this whole thing so powerful. And again, that's why making a function call or deploying a contract costs a little bit of gas. Now, the reason we can access this favorite number variable inside this function is because favorite number has this global or contract scope. So even if we made uint 256 test equals 4 or equals 4, we wouldn't be able to use this variable outside of this function, right? Because it's self-contained. It's self-contained inside this bracket. And if I were to make another function, store2 perhaps, public, store2 doesn't know that this test variable exists. Functions only know about the variables that are in the same scope as them. So favorite number is in this global scope because the only bracket that's above them is simple storage. And test is in this store scope because it has 2 brackets above it. It's inside of this store function and inside of this contract simple storage. Store2 isn't inside of this store function or this store scope, so it can't access this test variable. So let's go ahead and make this back to public. And we'll compile. Again, I'm hitting Command S to compile, but you can go ahead and click the button if you like. And let's get rid of this and get back. Now, as you saw, when we deploy this, there's this button here that we can click called favorite number. We can also make a function called retrieve and make it a public function that is of type view and returns uint 256. And all this is going to do is return favorite number. So we're going to talk about views and returns here. So I'm going to go ahead and compile. I'm going to go ahead and delete this contract. I'm going to go ahead and deploy it now. And we can see now we have 2 functions or 2 blue buttons here. We have retrieve and we have favorite number. And if I change favorite number by calling the store function, favorite number and retrieve will both now say it's 1, 2, 3. So then the question might be, well, why is this one orange and these 2 are blue? And the key relies in this view function or this view keyword. There are 2 special keywords that define functions that you actually don't have to make a transaction on. And those keywords are view and pure. A view function means that we want to read some state off the blockchain. So we're just reading off the blockchain. If we're reading off the blockchain and we're not actually making a state change, then we don't need to make a transaction. These blue buttons are blue because they are view functions. Public variables also have view functions. That's why both of these are blue. This technically is a view function. And when I click it, I get to view and I get to read the state off the blockchain. Retrieve is the same way. We could have this without a return, but it wouldn't do anything. Pure functions are functions that purely do some type of math. We could have uint 256, favorite number, public pure, and just have favorite number plus favorite number. So we're doing some type of math here, but we're not actually saving state anywhere. We're going to do this math, but we're not going to save this favorite number anywhere. We're not going to save anything. Deploy this now, this pure function. We would have this retrieve function, 1, 2, 3. It's blue as well because it's, again, not going to change the state of the blockchain. So view functions and pure functions are both going to have this blue color. Now, the reason that nothing shows up at the bottom is because we didn't return anything. All we're doing is we're saying, add these 2 numbers together, and that's it. In order for this function to give us something back, we need to have it return something. So if we go back to this retrieve function, we have to define what we're going to return when we're defining this function. So we're going to say this is a public function. It's a view function because we're going to read some state, and it's going to return a uint256. So favorite number is a uint256, so that's what we're going to return. Our public variable favorite name is also a view function that returns a uint256. For now, let's just remove that so we can work with this retrieve function. So let's go ahead and deploy. So now we see we don't have this favorite number button anymore because it is no longer a public function. Because again, it gets initialized to internal, so we can't actually view it. Now keep in mind, later on, we're going to talk about how everything on chain you actually can see, and we'll talk about that a little bit later though. So retrieve is going to do 0, we can call store, and now retrieve is going to be 1, 2, 3. Now this application is great so far. It allows a single person to store a favorite number and then go ahead and retrieve it later, which is fantastic. But what if we want a list of people or a group of people and store their favorite numbers? Or what if we want to associate a favorite number with a single person? Well, what can we actually do? Now we have a whole number of different choices, but the one that we're going to talk about is using a struct. Structs are ways to define new types in Solidity. They're almost like creating new objects as well. So we can create a struct called type people and allow it to start storing a favorite number associated with a certain people. So inside of our struct, we can have different types as well. So we can have a uint256 favorite number, and we could also have a string name. Now we have a new type of type people that has a favorite number and a name inside of it. Now what we could do with the struct is we could say people public person equals people, and then inside we add the variables. So we could say favorite number, favorite number is 2, and name is Patrick. And of course the semicolon at the end. And again, I'm hitting Command S to save, but you can also go ahead and compile in the compile tab. So let's go ahead, delete this contract, and see what this looks like now. So now we've deployed this new contract, and we have this person struct, which at the 0th index is the favorite number, and the variable stored in the first index is going to be the name. Storing variables in Solidity always works in this numeric index fashion. In fact, in contract simple storage, uint256 favorite number is at index 0. If we were to add another object here, like boolean favorite bool, this would be at index 1. If we were to add bool favorite bool 2, this would be at index 2. 0, 1, 2. And it works the same in structs. This is at index 0 inside the struct. This is at index 1 inside the struct. So we can see the variables associated with this person. We're going to go ahead and delete this for now, because instead of just creating one person, we actually want to create a whole list of people. So how do we create a list of people? Let's delete that contract. And what we can do is we can make what's called an array. An array is a way of storing a list or a group of some object. So as you're starting to see, the way the syntax works for defining any type of variable is going to be the type of the variable, the visibility of the variable, like public, or if you don't declare it, it gets initialized to internal, and then the name of the variable. It works the same with arrays. So we'll make a people array. The people array is the type. We'll make it public, and we'll call it people. Now if we deploy this contract, we can go ahead and see we now have a people array. But if we click this button, you'll see that nothing shows up. And the reason is because it's an empty array to start with, right? We don't have anything inside of it. Now, this type of array that we've created is what's known as a dynamic array. It's a dynamic array because it can change its size. Right now, it's of size 0, and if we added something to it, it's of size 1. You can also create arrays of a fixed size. So if I were to do people 1, public people, this array could only have a maximum of 1 person inside of it. So we're going to work with a dynamic array though, because we want to add an arbitrary number of people into here. So let's go ahead and create a new function called addPerson, where we can add a person to this array. So we'll do function, add person, string, memory, name. I'll talk about this memory keyword in a minute. Uint 256, favorite number. And then we'll make this a public function. And inside, we'll add this person to our array. The way to add a person to your arrays is using the push method. So we're going to push a new people or a new person, and we're going to give it those variables again. So we're going to give it favorite number is this variable that we passed in here. Oops, this needs a bracket. And then we're going to give the name, going to be this underscore name. And then end bracket. Oops. Zoom out again here, just so I can see stuff. This needs a semicolon. And perfect. Now, in that last clip, we saw this little red box pop up. Whenever a little red box like this pops up after you compile, it means you have a compile error. This means that there's something wrong with your Solidity code or your Solidity syntax, and it won't compile and deploy properly. Red is going to be this compile error. Now, we're going to see a bunch of yellow warnings in the future. If you get a little yellow pop-up, these are okay to ignore, but they usually have some helpful tips about something that might be going wrong in your code. So to summarize, if it's red, it's broken. If it's yellow, you might want to check it out, but it could be okay. So we can see we have our new function add person, where we pass a string memory name and a uint 256 favorite number. And then we create this people person, this people object here, and then we push it onto our people array. And I'm going to show you another way we can actually create our people person is just by passing favorite number and name. I'm getting rid of this other bracket by passing favorite number and name. Because we know that the 0th index of people is favorite number and the first index of people is name. So we can also create a new person by adding it like this. Now let's talk about this memory keyword here. Now in Solidity, there's more or less two ways to store information. You can store it in memory or in storage. When you store an object in memory, it actually means that it'll only be stored during execution of the function or of the contract call. If we hold it in storage, that means that that data will persist even after the function executes. A string in Solidity is actually technically not a value type. A string is actually an array of bytes. A variable of type string is actually a special type of array that we can append text to. So because it's technically an object, we have to decide where we want to store it, in memory or in storage. And since we only need this name during the execution, we can have it be string memory name. And then when we create this new people object, we will create a new copy of this name variable into storage. Memory means that after execution, delete this variable, and storage means keep it forever. If this is a little bit confusing for you, just know that for now, when you use a parameter that's going to be a string for one of your functions, you need to call it string memory. So let's go ahead and deploy this contract and see what happens now. Now we have this new function, add person. And since we are making a state change here, we can see that this indeed is a orange button instead of being a blue button. So we can add in here a string name. We'll add Patrick, and we'll say his favorite number is 2. Again, right now, if we look at people, we see people 0, there's nothing in here. If we retrieve, there's nothing in here. So we're going to add person Patrick, and now if we hit people of 0, we can see that the person at the 0th index in this people array is going to be string Patrick. If we try at 1, there's nothing in here. Let's add another person. We'll add Becca, and her favorite number will be 24. Let's add her. Now if we hit 1, we see favorite number 24, string name is Becca. And retrieve is still showing up blank because we haven't touched favorite number. Awesome, this is great. We can just keep adding people. However, there is kind of an issue here. What if I'm looking for a person? What if I'm looking to find Becca and find her favorite number in this array? What if I know her name, but I don't know her favorite number? Is there an easy way for me to find that favorite number without having to triage the entire array? There's another